Dams are some of the world's most impressive feats of engineering. In the US alone, there are more than 90,000 of them, generating electricity, controlling flooding, and supplying water to their surrounding communities. Like these 4 dams here, sitting on the Klamath River, stretching across the Oregon-California border.
But there's a big dam problem. These structures aren't so great for the river's fish or water quality.
After more than a decade of debate over money, ecology, and salmon, officials called for a drastic move: the demolition of all 4 dams.
And this is the largest river restoration and dam removal project that's ever been undertaken.
The Klamath River is known for its stunning scenery and wildlife. It flows for more than 400 kilometers through parts of Oregon and California and drains a basin covering 31,000 square kilometers. At one stage, the river was home to the 3rd largest salmon population on the west coast, providing a vital resource to local indigenous groups. But that all changed when these hydroelectric dams were built in the early 1900s. From around 1895 to 1915, breakthroughs in hydroelectric design led to the construction of many new dams and power plants, like these ones here in Klamath. Today, the dams produce enough energy to power 70,000 homes at their peak, although they aren't usually operating at full capacity because of low water levels and some other issues. And like almost any major infrastructure project, there's always a trade-off. While these structures have stopped potential flooding, provided tax revenue, and created great spaces for having fun, they've also blocked the fish from reaching their spawning habitats upstream. Because of that, the salmon population has dwindled to less than 10% of its original volume. And that's not the only impact of the dams. During the warmer months, the waters are frequently plagued with toxic blue-green algae blooms, which occur when nutrient-rich water gets trapped in the shallow reservoirs. Environmentalists and local tribal groups have long fought to find a solution, while some homeowners worry that removing the dam will cost them in tax money and lost property values. In the end, Pacificorp, the energy supplier itself, said that removal would be cheaper than the alternative of building fish ladders, and that the electricity the dam generated could easily be replaced. Then, in 2022, the Federal Energy Regulatory Commission officially authorized the $450 million removal of 4 major dams: Copco Dams 1 and 2, J.C. Boyle Dam, and the Iron Gate Dam. No dam project of this size has ever been torn down before, and it's going to take meticulous planning and construction work to get it right. And of course, it'll be costly. With operating expenses factored in, it would cost an estimated $20 million per year to maintain the dams and address the water quality impact in their current condition. So removing them saves money longer term. So as it turns out, there are 2 methods to remove a dam: instantaneous or staged. Instantaneous removal happens quickly, think hours or days. We know, not exactly instantaneous, but pretty quick. Here, a reservoir drawdown takes place, which is a process that involves releasing the water and built-up sediment stored behind the dams downstream. Now, most dams have an emergency drainage system in case the water level needs to be lowered quickly. That usually takes the form of either a low-level conduit, which is basically a channel that can be opened for water to flow through, or a stop log, which is essentially a stack of logs or beams that can be raised to let water through. Once the water is released downstream, the dam itself is demolished with explosives, that's the instantaneous bit, and the rubble is removed from the site, that's the bit that takes a bit longer. Conversely, staged removal happens over a longer period of time, usually months or even years. This method is reserved for taller dams with larger amounts of built-up sediment that would pose environmental risks if released too quickly. In a staged demolition, rivers are pumped or diverted away from the construction site through tunnels or channels, allowing for more control during the reservoir drawdown and sediment release. Once the rivers are diverted and the basin is dry, the dam is demolished using tools like excavators or explosives, depending on the material. It's this longer staged method that's being used as the basis for the Klamath Dam removals, albeit with some slight variations depending on the size and materials in each dam. Ultimately, this project will return the river to its free-flowing condition. Starting in 2023, Copco No. 2, the smallest of the 4 dams, is going to be the first to be demolished. Now, unlike the others, Copco No. 2 has no real reservoir, so drawdown isn't going to be necessary. But that is going to have to take place at the other 3. In early 2024, crews are going to open up low-level outlets for the rest of the dams to slowly initiate drawdown of water and sediments at a rate of around 1.5 metres a day. The 3 remaining drawdowns will take place at the same time, taking advantage of the water power to help mobilise and push water and sediment through. The river will then be diverted through new or existing diversion tunnels from the original construction of the dams. That'll cause the channel to dry up so demolition can take place safely.